class. And today what we're going to do is we're going to start problem solving using this thing called the mole. What we're going to do here today is I really want you guys to get out a piece of paper and be doing these steps along with me. It's not going to help me unless you're actually writing this down. So if you need to, take a minute and go ahead and pause this video and go and grab a piece of paper and a pencil and make sure that you are doing the work alongside with me. And one of the easiest ways of going about problem solving steps with the mole is to just kind of jump right into it and go through the process with me. So what I'm going to do here is we're going to always start with what you know. We're going to always cancel our units. We're going to finish with units that you need in order to solve the problem, and that's going to be very important. No naked numbers. Always have units. Do the math. Multiply everything on the top. Divide the bottom. Ignore ones. We don't really worry about those. And then we're going to round our answer to the correct sig figs and making sure that we write our units. This should look familiar. We're basically going to be using dimensional analysis, which we've already done earlier in the year with conversions. So what we're going to do is we're just going to go ahead and jump right into it. Remember, we've been talking about the mole. This is 6.02 times 10 to the 23rd. And it doesn't matter what we're talking about. If somebody says how many pennies are in a mole, it's always 6.02 times 10 to the 23rd. How much is a mole of basketballs, a mole of molecules, a mole of atoms, a mole of formula units? We're always talking about 6.02 times 10 to the 23rd. So we're going to use that knowledge to help us solve some problems. So we're going to go ahead and start with example number 1. How many atoms of carbon are in 2.5 moles of carbon? So remember, it says a mole of carbon. It's 6.02 times 10 to the 23rd. So we're going to use the factor label method. And remember, rule number 1, start with what they give us. All right, they told us we have 2.5 moles of carbon. But we don't want to be in moles of carbon. We want to be in atoms of carbon. So we're going to use what we know as our conversion factor. So because 2.5 moles is on top, we're going to put 1 mole on the bottom. And our conversion factor is there are 6.02 times 10 to the 23rd atoms of carbon in 1 mole. We're going to cancel our units. Mole on top, mole on bottom, it cancels out. And we're left with atoms. And if we look at the problem, it says how many atoms of carbon are in 2.5 moles. So we're there. We just have to do the math. So on your calculator, you're going to go 2.5 times 6.02 EE23, if you have that EE button. And you should get 1.5 times 10 to the 24th atoms. Notice that we started with 2 sig figs, 2.5 moles, and we're going to end with 2 sig figs, 1.5. But don't forget the times 10 to the 24th atoms. Okay? So we're going to do this a lot, so don't worry. All right? So in your calculator, because these guys are on top, we're going to multiply them. 2.5 times 6.02 EE23. If you need to, pause the video, do the math, and then make sure you're getting the same answer as me. Okay? All right, example number 2. How many molecules of carbon dioxide are in 8.2 moles of carbon dioxide? So we're always going to start with what they give us. What did they tell us we have? We have 8.2 moles of carbon dioxide. But I don't want to be in moles. I want to be in molecules. How many molecules are there? So we're going to set up our railroad tracks. Remember that if you have 1 mole, then you have 6.02 times 10 to the 23rd molecules. So we're going to put mole on the bottom so it cancels out. And we're going to put our 6.02 times 10 to the 23rd molecules on top. And there we are. We're done. We have it in molecules. So in our calculator, we're going to put 8.2 times 6.02 EE23. And we started with 2 sig figs, so we need to make sure that we end with 2 sig figs. And when we're dealing with scientific notation, we only care about the part that's before the times 10. So we have 4.9 is 2 sig figs times 10 to the 24th molecules. Again, push pause, put this in your calculator, make sure you're getting the same numbers as me. All right, here's a little bit different. So it says it says how many moles of gold are in 5.9 times 10 to the 21st atoms of gold. So start with what they give us. They say we have 5.9 times 10 to the 21st atoms of gold. I don't want to be in atoms, I want to be in moles. Again, we're going to use that conversion unit. Except for this time, we're going to put atoms on the bottom so that it cancels out. And we're going to put 1 mole on top. So our atoms cancel out. And we're left with moles. That's what we want. Because we have the 6.02 times 10 to the 23rd on the bottom, we're going to divide these. So if you can get out your calculator and go 5.9 EE21 divided by 6.02 EE23, you should get something about 0.0098 moles. Notice we started with 2 sig figs, so we're going to round our answer to 2 sig figs. And zeros in front never count. So 98, that's 2 sig figs. Number 4, how many molecules of water are in 4.3 moles of water? Always start with what they give you and see where we need to go. So we have 4.3 moles of water. I don't want to be in moles of water. I want to be in molecules. So we already know that if you have 1 mole, you should have 6.02 times 10 to the 23rd molecules. Moles cancel out. These guys are on top, so we're going to times them. 4.3 times 6.02 EE23. Do the math on your calculator. We started with 2 sig figs. We're going to end with 2 sig figs. 2.6 times 10 to the 24th molecules. You should be seeing that we're only really using the 1 mole is 6.02 times 10 to the 23rd. Whatever we're talking about, that's our conversion factor. And last example for this section, just dealing with numbers. How many moles of sodium chloride are in 3.7 times 10 to the 24th sodium chloride formula units? Let's just start with what they give us. They say we have this many formula units. Well, we're trying to get to moles. 1 mole of anything is 6.02 times 10 to the 23rd. Whether we're talking about atoms or molecules or whatnot, here it's formula units. We can cancel those guys. One's on the top, one's on the bottom. We're going to divide them. So in your calculator, you're going to go 3.7 EE24 divided by 6.02 EE23. And notice that we started with 2 sig figs. We're going to end with 2 sig figs. So you should get about 6.1 moles. Please make sure you try this on your calculator as well so that you're entering it and you're getting the same answer as me. All right, so that should be pretty simple. We're just going from either moles to atoms or molecules to moles, you know, when we're talking about numbers of a mole. That's our only conversion factor. But sometimes what we can do is we can actually use the molar mass of an element to convert between the mass of the substance and the moles of a substance. And you guys should be really used to doing molar mass by now. So if we know the molar mass of a compound, we can actually convert to moles. So 1 mole equals however much the molar mass of a compound. So let's go through just a couple examples of that, and then we'll do some practice this week. All right, 2 more examples, and I promise we're done. It says, what is the mass of 9.45 moles of aluminum oxide? Okay, so they tell us how many moles we have, and we know that we can get the molar mass of aluminum oxide. It's Al2O3. First thing that we need to do is figure out the mass of aluminum oxide. There's 2 aluminums, there's 3 oxygens. We're going to look on the periodic table and we're going to see the molar mass right there on the periodic table. Aluminums is 26.98. We have 2 of them. Oxygens is about 16. We have 3 of them. We add those 2 together and we can get the molar mass of aluminum oxide as 102 grams. So when it's asking for mass, we should kind of be thinking about, all right, we're going to have to deal with molar mass. We're going to have to calculate that. So let's start with what they give us. They say we have 9.45 moles of aluminum oxide, but I don't want to be in moles. I want to be in mass. So we can use the molar mass to convert. We know that if we have 1 mole of aluminum oxide, it's going to weigh 102 grams. So right there, we've converted out of moles. We're in grams. That's what it's asking for. It says, what is the mass if I have this much? They're both on top, so we're going to times it. And notice that we started with 3 sig figs, and we're going to end with 3 sig figs. So you should have gotten 964 grams of aluminum oxide is how much we have if we have 9.45 moles of it. All right, 1 more. How many moles of iron 3 oxide are contained in 92.2 grams? All right, we're dealing with grams here. Anytime we're dealing with grams and we have to kind of transfer in between grams and moles, we're going to have to get the molar mass. So iron 3 oxide's formula is Fe2O3. We're going to look on the periodic table. We're going to see, all right, what's that? What's the mass of iron? What's the mass of oxygen? We have a couple of each. We're going to add those together, and we're going to see that the molar mass of iron 3 oxide is approximately 159.7. Okay, so now we can go ahead and start with what we know. We know we have 92.2 grams of iron 3 oxide. I don't want to be in grams. I want to be in moles. Look at the questions. See, what is it asking? It says how many moles? Well, in 1 mole of iron 3 oxide, we have 159.7 grams. Our grams cancel out. We're left in moles. 1's on the bottom, so we have to divide them. Notice that we're starting with 3 sig figs. We're going to try and round our answer to 3 sig figs. 0.577 moles of iron 2 oxide. So hopefully you've been writing this down. You are taking some notes so that you can go back and look at it. I'm going to try and do another video going over a little worksheet and some practice here tomorrow. So thanks for bearing with me, guys, and I hope to see you all soon.